My name is Ben Ong. I'm a senior software developer here at Achievers and essentially one of the primary architects of our CI/CD process. I call this slideshow the journey because, in a sense, the evolution of our CI/CD pipeline here at Achievers really mirrors my own personal journey since joining the company as well. So the main goal of this talk is to kind of learn about the things that we did along the way. Where did we do well? Where did we make mistakes? And if we did make mistakes, what exactly is it that we learned from it, and how do we proceed along the path? This is what we really want you guys to take away from this is just learn the lessons that we learned and don't repeat the same mistakes that we made, so that you guys will have a more efficient, you'll have an easier and cleaner way on your CI/CD journey. So here's our introduction. So we'll start off with some key concepts, things you should know at the very beginning, key concepts on the journey that we have. We'll talk about where Achievers started off, where did we end up, or where did we start off with all the things that we did in the beginning, how was our process at the very start, and then we'll kind of get around halfway because around halfway through the journey we did make some decisions that were less than great, and then we will eventually reach the destination, which is where we are today. So key concepts. What is CI/CD? Continuous integration and delivery is a definition from Wikipedia, a long one, merging all of our developer working copies to a single shared mainline, and then making sure that that working copy is capable of being deployed at the end of the day. So here at Achievers, we have our own separate definition of CI/CD, which is that a developer should be able to merge their code into the main branch as they need to, obviously going through a key process as well. The second definition that we have is that we need to ensure that our master branch is in a stable and deployable state at any time. That's one of the main goals of our process. So what are some things you should have before you start? CI/CD is a journey, so at the beginning of your journey, you obviously have many things. Whenever we go out to travel, we always carry certain things with us. Similarly, for those of you who are gamers out there, at the very start of your journey in an RPG, they always give you basic supplies like potions and stuff like that, right? Similarly, on this journey, you should have certain things at your organization before you begin. The first one is that you should set up strict monitoring on your production environments. How many people here are working at companies who already monitor their production environments? All right, so a goodly number. If you don't, this is probably the first thing that you should do, just because even outside the CI/CD context, this is really useful because you at least know what's going on. Secondly, you need to be able to roll back quickly. Here at Achievers, our rollback process takes about 2 minutes. We press a button on a Jenkins job, and it automatically reverts everything back. The reason you need to do this is because when you push code to your production environment on a regular basis, no matter how good your test coverage is, no matter how good your pipelines are, inevitably bugs are going to creep through. You don't want those bugs having a long-term negative impact on your customers. You should control access to new features using feature flags. Once again, this kind of happens when you're moving very quickly, when you're constantly pushing new code to production. You don't want your clients and your customers experiencing a feature that is not ready yet, and similarly, they shouldn't see things that are not ready yet either. This is very important. This is one of the core tenets here at Achievers that we have to control access to new things, because our teams are constantly pushing things to production, and we don't always want the clients to know everything that's on there right away. Lastly, you should foster a culture of ownership within your engineering and development organizations. We push to production probably 3, sometimes 4 times a day. Our developers are very good at owning their tickets. They're really good at owning their code. And so when a change is made to production, our developers are all eyes on deck, keeping an eye on all the different monitoring tools that we have to make sure that nothing goes wrong. This is really key because when something goes wrong, people need to know what happened, and they need to be able to fix it for the next release as well. The next key concept is, and the final one, is the idea of a pipeline. This isn't the pipeline that carries oil and gas or liquid, by the way, guys. If you're here to talk about that, you have shown up at the wrong building. A pipeline here at Achievers, we define it as a collection of jobs that run on a specific set of code. This is an extremely broad definition, as I'm sure most of you guys know, because it could be like, hey, what if I'm just running my pipeline on 1 line of code? If you have a pipeline for 1 line of code, you're doing it wrong. However, it is essentially validating your code, and more importantly, it establishes a known bar of quality. The more, in the beginning, early phases of your CI/CD process, your pipeline's probably not going to be very robust. It'll maybe have a set of unit tests in it. It might have some syntax validation, but that's pretty much it. But as you expand the scope of your pipeline and include more and more tests in there, the established bar of quality constantly increases, and you are more confident as you go along. When you create a pipeline, it's important that you establish a set of core principles. What is the purpose of your pipeline? Why are you building it? What are the things that you want to guide your decisions? The key function of our pipeline here at Achievers is to identify critical problems. That's pretty much just the basic purpose of it. We need to make sure that we are able to catch bugs that before they go into production, and we need to be able to rectify and detect those bugs so that there's not any negative impact on our customers. What else? Your pipeline should probably be mostly automated. In fact, I would argue that it should be 100% automated. The definition of a continuous is, in the continuous integration and continuous delivery, is the idea of an unbroken whole, something uninterrupted. If you have manual processes, can you really call your process continuous? This is a key point for us too. Your pipeline should be reliable and stable. You don't want a pipeline that occasionally turns red for bad reasons. You don't want it being green when there's actually something wrong. And similarly, you don't want a pipeline that's red all the time either, because that really shakes the confidence of your developers. And lastly, your pipeline should probably have relatively short runtimes. Here at Achievers, we try to minimize the runtime of our pipeline through a number of strategies that I'll be talking about in future slides. But more importantly, you don't want a pipeline that takes 3 hours. How many developers here would like to know whether or not their code is broken 3 hours after they've written it? I feel sorry for you masochists out in the crowd. However, most of us want to know within like the first half an hour or so whether or not something's broken, right? So that is why it's good to minimize runtimes. These are two additional key points. The closer to the beginning of the pipeline you are, the faster you should fail. If the very first step in your pipeline takes an hour, I would argue you're probably not doing it right. Similarly, the further along in the process you are, the closer to the end you are, the more confident you should be in the set of code that you are running the pipeline on. So where did we begin? Here at Achievers, we had an extremely manual deployment process. Somebody would sit in front of a computer, log into a build box, and execute some script to push things to production. And similarly, everything was manual. We had a developer who would manually write the code. If you know how to make automated developers, please talk to me after this. In addition to that, we had somebody who would manually merge the code after validating it. We had somebody who would manually test the code, and then we would have somebody who would manually push it to production. This process was long, it was painful, it was not efficient. But fortunately, we managed to evolve it. So what did we do in the very beginning? The thing that we started off with, we wanted to create a small initial goal that would allow us to take the first steps on this journey. You should start thinking about just getting one thing working in the beginning. Here at Achievers, the first thing we did was to get our unit tests showing up in GitHub, or in whatever version control system that you guys like as well. It's important to start off with a small goal. When you're on a journey, you don't immediately think of a destination. If you're on a multiple day road trip, you should think about the immediate goal for the day. What is the city I'm getting to next? Similarly, on the CI/CD process, you should think about where do I begin so that I have a good starting point for my journey. Secondly, don't think about everything all at once. This is something I've learned working many years in this industry and outside of it as well. If you try to think about the end goal and what you're trying to achieve and all the things you need to do to get there, it's rather demotivating. So we managed to get our unit tests working in GitHub, but there was a problem. If your unit tests were reported as being broken, you could, as a developer, choose to ignore it. You could just be like, you know what? I'm okay with the fact that my unit tests are broken, and I'm going to merge anyway. This was clearly a problem. I remember an instance where a developer chose not to notify anybody about the fact they were merging into the master branch. and this caused a production break at about 2 o'clock in the morning. There were many people who were rather displeased about this. So, here at Achievers, we've got 2 separate pipeline jobs. We have a pipeline that happens before you merge into the master branch, and we have a pipeline that happens after you merge into the master branch. I'm sure some of you are wondering, why do we have 2? Isn't the CI/CD process supposed to be 1 pipeline only? Here at Achievers, we're rather unique, and we have 2 because, number 1, we only have a single integration branch. And secondly, our deployment process, that is taking our monolithic application and putting it onto a server somewhere, takes about 20 minutes. Once again, we want our pipeline runtimes to be short. We want feedback to be quick so that developers can make changes quickly as well. So what's the first pipeline that we have? Aptly named the pre-merge pipeline. This pipeline obviously runs before you have a merge, right? It'd be weird if we had a post-merge pipeline called pre. And it does unit testing, it does dependency validation, it does a whole bunch of syntax checks as well. These are basic checks. You'll notice that none of these operations require a server. How many of you here work with web applications? The build process for a web application is rarely short for large monolithic ones. And that is the reason why we have this pipeline. This pipeline, the goal of it was to give our developers comfort to know that the thing that they're merging into the master branch is not going to immediately break it. And secondly, this pipeline happens extremely early in the process. It's the very first step in our automated integration process. So what's the second pipeline that we have? It's the one that takes the application and puts it onto a server. So we do build and deploy, we test our external API testing, and we also test our Selenium on this pipeline as well. The goal of this pipeline is to ensure the integrity of the master branch. This pipeline detects errors. It determines whether or not that version of the master branch that's being tested is going to be turned into a release candidate. This pipeline happens later in the process, and the goal of it is to give confidence to not only the developers that contributed to the pipeline, but to the organization as a whole, that the branch that we are pushing out is actually stable and workable. That being said, when we first built this pipeline, we introduced a whole bunch of different testing to it. Needless to say, when you put a whole bunch of different testing onto your application at once, you start running into all kinds of problems. I'm seeing a number of smiles out in the crowd. Some of you definitely know the hell that I'm about to bring you through. So, there are 3 lessons that we learned from our initial iteration of the pipeline. The goal, the very first goal that we had is to stabilize. What is the situation? How many of you here have had tests with bad data? All right, so not that many. Let me tell you what happens when you have bad data. I remember a time, it was within my first year here joining at Achievers, and at the time our testing relied on live user data. That is data of the users on our production environment. We used one very specific user for all of our testing. Around a week before this incident happened, that user suddenly left the organization. How many of you guys are going to be able to guess what happens next? The moment that we tried to do testing with this user that was no longer a part of the organization, suddenly all of our Selenium tests turned red. There were about 100 of them. And we were just like, this is rather strange. So this kind of scenario does tend to happen. So what do you do? Stage your test data on your test environments in a consistent manner. If you're making a user, make sure that user has the same permissions every time. Similarly, when we added this, we no longer had a reliance on live user data. Secondly, make sure you have complete control over the environment that you're actually testing. I'm hearing some laughter out there. Some of you definitely know what I'm talking about here. This is why it's important to control your data. At this time, when we were doing testing on client feature sets. So this story is when we tried to do a test on a specific feature that was configured a certain way. The week before, the client had decided, you know what? We'd really like to change the way this feature works. And the configuration of the feature was changed. When we went in to test it, we didn't know what the configuration was, or the configuration was different than what we expected. Test failures. So what's the lesson here? Make sure you set up your test data on your test environment, and make sure your test environment is in a known state. You don't want to run tests on an environment that you don't know what's actually going on in the database. All of us, Well, here at Achievers, we work with data-driven applications. When your data is not good, your tests are probably going to behave really, really strangely. Lesson 2. So you finally got all your tests working, you state your data properly, everything's in a good state. But when I got here, our entire Selenium test suite took about 2 hours. Can you guys imagine what happens when you try to run 2-hour testing in your pipeline? People were definitely not happy. However, they were running for 2 hours because we ran them back to back. We ran one test, that test finished, we ran the next test, that test finished, we ran the next one. This is not a good way to do testing, guys. The best way to do testing is to parallelize. Take the tests that you have and make sure that you can run as many of them on different threads as possible. But obviously, this creates a problem because of dependencies. Think about this scenario. You have feature A, but this feature depends on another feature, feature B. You don't write your test in isolation. So what happens when you test feature A and feature B at the same time? And they have dependencies on each other, and they have different configurations from the standard as well. This was a scenario that we encountered a lot, and it was one of the main blockers for us pushing towards making everything as parallel as possible. But we managed to get around it by creating a parallel strategy that allowed us to test them using different waves. So here at Achievers, when we do our testing in parallel, we don't run using a standard queue system. What we do is split our testing up into different phases where each phase tests different features. So your first 5 tests will be 5 completely independent features. The next 4 or 5 will be completely independent from each other as well. This was the way that we were able to shorten our test run times from 1 hour and 30 minutes to about 20. This was a really, really big stride for our organization because it significantly reduced the turnaround time. The second thing that we did was we distributed as many tests as possible from our Selenium test suite into API. Selenium testing is rather slow. It's really unstable. It's brittle. It's not as immune to change as something like an API endpoint. However, that being said, when we did this did come back to bite us back a little bit down the road. So what's the lesson that we learned here? Shorten your runtimes by creating a parallel strategy that works for your organization. You definitely want to parallelize things, but once again, be very careful of the dependencies. The parallel strategy that we do here at Achievers might not work for your organization. Maybe you guys have completely independent features and you can run 10 threads all at once, which would be absolutely awesome. So the third lesson that we had was we need to make our tests more maintainable. When we first got here, our test cases were definitely not written in a maintainable manner. We had extremely long test cases. It was frequently very difficult to tell what was going on. And I'll admit, in my very first week here, when I opened one of our Selenium tests, I immediately wanted to leave. It was pretty bad. Furthermore, we had a lot of timeout problems due to bad infrastructure, where our nodes had extremely long, short timeout times. Our servers were not able to keep up with the load that we had been placing on them with multiple threads. So what is the solution? Improve your test writing. I know this sounds really, really simple, right, guys? But it's actually really key. How many people here have worked with Cucumber? For those of you who don't know what Cucumber is, it's something that lets you write tests in an easily readable manner. It takes a bunch of different test steps and lets you obfuscate the details by writing them as text. Here at Achievers, we have a very similar approach. We took all of the details that were not being obfuscated in this 1,000 plus line test case, and we split up all the details into multiple tiny steps as well. The second thing that we did was we really improved our architecture. We added more nodes to our Selenium grid. We adjusted our timeouts so that they were longer. And more importantly, our Selenium testing now runs on a multi-server environment so that we have a lower risk of timeouts. This really, really helped us a lot because it made our tests a lot easier to deal with. Simplifying your test writing is something that seems very basic on the surface, but it actually really helped our organization a lot. We were able to delegate a lot of the test writing off to developers. Our API testing is extremely straightforward to write because it uses Mocha and all it is a wave of JavaScript. And more importantly, developers could look at existing testing as a reference so that they could take the examples that we have given them and then add testing on their own. All right, we're about halfway through. How many people are still awake? I'm glad for it. Are you guys all still with me? Yeah. Do you guys all know the number of fingers I've got up? Yes, at the end. If you do have questions, please keep them in mind. We'll definitely have a Q&A at the end. So this is what our model looked like at about this point. Gosh, I hate staring at this thing, but in the middle is our master branch, the integration branch that we do all of our testing on. At the very top is the pre-merge pipeline, where we have unit testing, all that stuff that I talked about at the very beginning. However, you'll notice that this pipeline structure down below for the integration is markedly different than what I talked about initially. It was because around this time we had split the API testing and we had also split the Selenium testing. This regression pipeline described here is the pipeline that actually ran the Selenium testing. However, there was a problem with it because it didn't block you from making a release candidate. The post-merge pipeline would stop you from making a release candidate, but only if there was an error with the API testing. However, we had another pipeline here, which actually was pretty much a copy of the Selenium pipeline, that would actually stop you if you had an error. So the lesson that we have here is we had pretty much distributed our process across too many different areas. So let's talk a bit about automation here. Automation is important. We have, in the very beginning, we had an extremely manual deployment process. Somebody would log in to a computer, they would sit there, and they would type a command. I'm going to recall a story from around a year ago. We had been working here at Achievers for around a year and a half. It was in October, I believe, of 2017. Our build engineer for the day had come into work. He had logged into the build box at about 10 o'clock in the morning. And we name our release candidates by year. So, for example, on this day, I believe it was 2017 1004 or something like that was the name of the release candidate. I think he might not have had his coffee yet, because when he typed the release candidate into the box about what we were going to push to production, he typed 2016. What happens when you push code from a year ago to your production platform? We immediately had about 1 million errors on our monitoring, and it was bad. I believe that our systems team must have spent about 3 weeks cleaning up the mess that we made from leaving year-old code on production for about 10 minutes. This is why you guys need to automate your processes. Make sure that you know what you're pushing to production. Don't let a person do it. This was a process that we started off this year, and it sounds really simple on the surface, right? You just make a Jenkins job, the Jenkins job calls the deployment process, and everything is good, right? Not really, because we had a problem with compliance. We needed to create all of these documents for bookkeeping. We needed to make sure that we met all of the compliance requirements required for our releases to make sure that we weren't in violation of any of our licenses. I think here at Achievers, we send out about 2 or 3 notifications. We create a whole bunch of documents on network drives, and all that stuff gets stored onto an archive server somewhere. We wrote code to automate every single one of these steps. It's really great these days. When we log in the morning, nobody needs to do anything. The production deployment automatically kicks off on a schedule, and nobody has to do any manual interference unless something goes wrong. This is the way the automated processes should be. You should automate your process as much as possible. If you're not automating, what is your reasoning? There are certain areas that are not good to automate. Anybody here who has worked with presentation testing will know what I'm talking about. Verifying the front end of a platform and making sure it looks, quote unquote, correct is rather difficult. However, automation is the backbone of CI/CD. This is the real spinal column of the human. Without automation, there's no way to realize this true CI/CD process. So it's important to know which areas can I automate, and if I can't automate them, can I find a way to automate them? If we're definitely not going to automate them, what is the reasoning? Lesson 5, unify. We had many, many, many different pipelines. In this structure, certain things would block the build immediately, certain things would block the build later, and the feedback loop required was really, really not good. I'm going to stop here and talk a little bit about the idea of criticality. A lot of people here have heard the word, I'm sure that some of you have actually heard the phrase, if everything is critical, nothing is critical, right? But if everything is critical, it means that anything can stop your process. And in the case of CI/CD with a pipeline, you definitely want bugs to stop your process, regardless of whether they are small or big. Here at Achievers, we have one unified level of criticality. It's that if anything breaks our pipeline process, or if any of our testing detects a bug, that build is regarded as not a good release candidate. So what did we do? Put all the pipelines together. Sounds simple, right? However, at this time, because of a number of design decisions that we had made about the pipelines, this was actually an extremely difficult exercise. To give you guys further context, at around this time, Achievers had not one, but two different Jenkins environments. Our Selenium testing ran on a separate Jenkins environment than our API testing, targeting a different server. And the API testing was good, but the Selenium testing required specific architecture. And that is pretty much Selenium Grid. Selenium Grid is something that lets you run things in parallel. I'm not going to go crazy into depth about it, but that's pretty much the objective of it. This Selenium Grid architecture was tied to one Jenkins environment, so we had to migrate everything over. This entire process here to unify the pipelines probably took about 3 months or so. And it was definitely not an easy task, but it was definitely worth it because then we could create a single unified gate that would automatically detect any form of error and would stop the build immediately. We didn't have to go and notice that there was error with the UI pipeline, go talk to the developer directly and be like, hey, by the way, this change you made actually broke our build. Can you fix it? But then the developer will not feel any sense of urgency because it wouldn't have turned the pipeline red. Keep everything together as much as possible. This is the number one lesson that I felt that here at Achievers that we made that we could have avoided. If we had taken our processes and discovered all the areas that we had issues, fix those areas by temporarily removing them, and then putting them back immediately. Don't do what we did, which is that, hey, you know what, this area is slightly buggy. We should probably fix it all before we put it back. No, just introduce things one by one. It's okay if you have some degree of separation, but the ultimate goal at the end should be to unify everything together. Lesson number 6, adaptation. Developers feel the need to change the release candidates. This is not an uncommon scenario in the software development world. People feel their fixes are critical, and some of them are critical, and they need to go out quickly. The problem with changing a release candidate is that not only did we have to manually insert the developer's commit into the build, we also had to take this particular area, run it through a whole bunch of compliance processes, which required us to write a whole bunch of documentation, modify existing documentation, all manually, by the way, and required the new release candidate to go through an entirely separate process of testing, which was the deployment pipeline. This was definitely not a good thing, because it made it so that we couldn't adapt to change quickly, which is one of the key processes. So what's the solution? Using our unified pipeline that we had talked about in the previous slide, constantly use that pipeline to generate new release candidates. The pipeline is a single gigantic gate, right? So this pipeline should then therefore be the main deciding factor as to whether or not a release candidate gets created. We no longer create release candidates manually. The master post-merge pipeline is the thing that actually generates a candidate, and at the same time is the thing that validates whether or not that candidate is correct. Obviously in the reverse order, in that it actually does the testing for the candidate before it decides, hey, this candidate is fine. I'm actually going to mention here that it's really important that your CI/CD process, whichever pipeline structure it is that you have set up, is actually self-validating. You don't want to have a candidate created when things are definitely broken. And similarly, if things are green, you don't want to have to manually go in and trigger the candidate build yourself. Make it so that the thing that does the testing is the thing that determines whether or not your candidate is good or bad. Maximize your options. Limit manual work. Continuous delivery is continuous. I have heard that some places do manual approvals, but I do believe that you can automate those areas as well. So where are we at now after going through all of those things that we have done previously? Number 1, we do 3 deployments a day. We push at 10 o'clock in the morning, 1 o'clock in the afternoon, and 3 o'clock in the afternoon as well. You'll notice that these are all inside business hours. We don't do deployments at 2 o'clock in the morning for obvious reasons, because nobody can tell whether or not anything goes wrong. Our integration pipeline runtime is about 40 minutes. This is a pipeline that runs about 3,000 API tests, and it runs about 100 Selenium tests as well. Our stability rate is about 80 to 90%. We have pretty much eliminated false negatives, as in the pipeline breaking when it shouldn't have. And this was definitely a major accomplishment for us getting to these success numbers. I mean, in the beginning of this year when we had unified everything, our success rate was about 50%. It was definitely not good. But through all number of stability measures that we have taken, we're now up to this number. And lastly, a key point about all this is that our deployments are completely automated. The only thing that gets done during a deployment is a notification gets sent out to our company channel, and it says a deployment is beginning. And similarly, when the deployment is done, the deployment actually automatically posts to the channel that's complete as well. Where are we going next? Where are we going on the next steps on this CI/CD journey? There are a lot of different options, mostly because we are dependent on the structure of the application. The way that you do the CI/CD process with something like Docker or Kubernetes or any form of microservice is going to be completely different than the way that we do it with monolithic applications. And we're currently trying to decide what are we going to do with the pipeline. What is the best way that we can spend our time to get the most value out of the pipeline that we have right now? Our pipeline is in a really, really good spot. It's the main validating gate for everything. But that being said, I still believe there's a lot of room for improvement as well. So let's just have a quick recap to go over all the things that we learned. Number one, make sure you know what's going on in your test environments. That's pretty much what this lesson is. Set up your test environment to make sure it's in a known state. Number two, make sure your runtimes are short. One of the pipeline principles is that we want short runtimes. We don't want 3 hours. Number three, write your tests in a way that is easy to understand and maintain. Furthermore, this really makes it so that your developers can write your tests as well. Maximize your options. Create lots of different release candidates so that you are less vulnerable to sudden change. If you already have release candidates that's validated and it has the fix in it, why don't you just push that one? And not lastly, there's one more after this. Automate your process as much as possible. Automation is the key backbone of CI/CD. It's the thing that drives all the different processes. If you're not going to automate a certain area, you need to understand why you're not automating it. And lastly, make sure your processes are as unified as possible. You don't want to do the same thing that we did, which is suddenly distribute all our processes for reasons that made sense at the time, but were not actually good. Keep everything together. It's a lot easier when you have one gate instead of 5. All right, we're going to go on to questions. For those of you who don't know, magic is a really big thing here at Achievers. This slide is for a creature called Question Elemental, and it is made up entirely of question marks. I sincerely hope you guys don't have as many questions as question marks on this creature. Okay, let's begin. Who wants to break the ice? Yes. So the question was, how do we integrate our CI pipeline with external APIs effectively? We actually have an internal wire mock server that mocks the response to third-party APIs, because the sense of responsibility here at Achievers is that we are only responsible for our own code. We are not responsible for third-party API breaks. So what we have done, one of our teams, is that they actually have created a server that when you send a request from a test environment to a specific address, that server sends a predetermined response back. So this way that you can at least be sure of the functionality of your own code, irrespective of the state of a third-party API.
So basically mocks.
Yes, we use mocks effectively, yes. Any other questions? Yes. So the question was, do we do performance testing in our pipeline? The answer is that we don't, because, well, there's 2 main reasons. Number one, our front-end testing runs completely in parallel. It simulates 5 to 7 different users, and that might not be enough, but it's normally able to tell if you have multiple sessions going on whether or not there's a sudden spike in the load. The second thing that we do here at Achievers is that we actually monitor our production environment's response times, and we can definitely tell if there's a sudden spike after a deployment. And in fact, if there is a sudden spike after a deployment, it's likely a good reason about why you should roll the deployment back. Yes? So the question was, did we ever have a situation where we had to roll back multiple days? So your question is rather loaded, so I'll give you a rather loaded answer as well. We have never had a situation where we had to roll back multiple deployments. And the reason is because our test coverage is written in such a way that all of our core features are actually tested extensively. We actually have multiple coverage of several of our core features as well in the test suites. So if there is a key problem that is identified, normally it's detected at the pipeline level. If it's a non-functional error, I would argue it's probably not a good reason to do a rollback as well. Our production monitoring level allows us to detect things like that. We've got like extensive monitoring all over the different production areas. And to be fair, even if we did have to roll back multiple versions, I'm sure that wouldn't be a problem. So Achievers, we work with a web application, right? So our Apache config is basically done using symlinks. And so we would just revert the symlink to whichever is a quote-unquote stable build. We don't delete old builds off production except on a specific cycle. So even if we did have to roll back 5 versions, it would just be a case of finding out what is the hash or the deploy tag for this version, and then we would roll back to that particular state. Our pipeline doesn't actually push to production. Our pipeline generates release candidates, and then we have a process that happens on a specific schedule, and it's on a completely different Jenkins box because of compliance requirements, once again, that actually does the production push. And the way that this works is that it looks at the version that's on production, it looks at the version that is the newest release candidate. If they are different, it does a whole bunch of different compliance-related operations, and then it does a new build up to production. So we don't actually have manual testing here at Achievers. All of our testing is fully automated because our test suites are functional focused. So we have front-end testing that automatically determines whether or not the front end is okay. And similarly, we have API testing that covers the back end as well. Thank you guys for listening to me jabber on for about 30 minutes about our CI/CD process. I hope that you guys all managed to learn something from us and that you guys can embark on your own CI/CD journeys and not forget the lessons that we have taught today. Thank you.